Okay, now we're going to look at doing a 2D contour around the outside perimeter of the octagon shape. That'll remove a lot of material that would have to be roughed away by other commands. Now we could use the 2D adaptive cutting for this, but typically I would just profile around something like this that isn't really that complicated and do an extra roughing pass in the XY axis. So we're going to go to 2D. We're going to do 2D contour. We're going to use the same cutter. And we're going to move along to the geometry tab. And we're going to profile around the bottom profile of the part. Now you could select this top profile here, or you can select the one at the bottom. And I prefer to select the bottom typically. And then we're going to go and set our tool orientation. So even though it looks correct, we're going to hit Z-axis and X-axis to make sure that our orientation of our spindle is in the correct orientation for this cut. Then we can go to Heights tab, and depending on what we're doing, it looks like we're going to take off from stock top because we've already milled the face down. And that gives us an error in offsets, but as soon as we fix the next one, it'll adjust. So we're going to go from model top on the top heights, and our error goes away. The next, we're going to go and select the bottom. Now we do need to select something different than the contour because we need to cut past where that edge is. So we have clearance for other cutters to come in and clean up those other edges. So what we're going to do is we're going to select the lowest selected at model bottom. And that should be fine. We've got some material in between the dovetail and the part. So we got close to a 1/4 inch material there. So our cut will cut to that blue plane, which says bottom plane. Now we're going to go to the passes tab. We're going to set in computer to where for the compensation type. That allows the operator to compensate for the cutter offset. Most of these we're going to leave at default. Okay, we are going to select roughing passes. And the maximum step over is pretty big there. So we're going to put, we're also going to leave it at 1/4 inch, and we're going to go to multiple depths. But no finishing step downs. And we're going to do, because there's no finish on the bottom of the part, we are going to finish only at final depth. And we're going to select use even step downs. Okay, we go to the next tab, 3 axis, and then we go to the linking tab, and most of the stuff we just leave at default. We're going to set the vertical lead-in radius to 0. And again, we don't need a ramp for this. We can just plunge this type of cutter in aluminum. We do want to set a preferred start location. I want to be able to have the operator see it when it starts. This is what's facing forward. That way the cutter starts on one of the front faces of the part. So could put it here, but I think I'm going to put it over here on the right. Okay, so our cutter should start near there, and we're going to hit OK. There we go. So we got a pretty good healthy cut with a healthy finish cut. It looks like it's knocked the corners off. That's what we want. We don't have any material left there for another cutter to run into. Okay, we now have this part profiled, the bulk of the material removed. So now we're going to do a command called multi-axis swarf. And this command will allow us to drive an end mill at an angle in 5-axis to cut the large chamfers on the face of the part. Okay, in this command, we are going to keep the speeds and feeds at default from our previous cutting. And we want to cut contours and contour pairs. Contour pairs. And what this does is you select two pairs of profiles. I have to make the stock invisible here. And the cutter is going to keep this, the software is going to keep the side of the cutter parallel to a line that bisects those two lines. So we want to pick the tops of the flats. We don't want to pick the other end of the chamfers, the fillets, or it'll machine those off. Okay, so we've got our two profiles, and it says to select the one that's lower in Z first. Okay, now we're going to set our axis of rotation, which in the case of this, it's already at model default, but because we're doing 5-axis, we want to make sure we can make a conservative effort to set it so we don't make a mistake. So we've got Z-axis pointing up and X horizontal. Now we're going to go to heights. We're going to select the model so that the software knows what geometry is the model itself. And we're going to go over to bodies and select the body of the model. Now we're going to go to heights. And my inclination is to leave things at stock top. And the cut is not going to go to model bottom. We don't want to go all the way down there. The tip of the cutter just needs to ride above just below tangency of the fillet. And so what we're going to do is we're actually going to select an edge. And we're going to pick the bottom reference being the bottom of the fillet. That allows the tip to go past that blue plane. Okay, but we don't want it to go any deeper, or a whole lot deeper. And then you just need one selection point for that edge to set the height. Now we are going to offset, and we're going to go negative 125, and that'll allow the cutter tip to go past the fillet that we see here, and assure that we've removed all the rough material. And that will also allow room for us to do this stock to leave. So we're going to do a roughing swarf and then a finishing swarf. So the roughing swarf is going to leave 10 thousandths on the face to be removed by another one. And we're going to go in an axial direction. We're actually going to go 1/8 of an inch deeper with that cutter. And again, that's to get the tip of the cutter past tangency on the fillet, so we don't have a cusp there. Especially in these corners where it wraps around, we could leave a cusp if we don't cut deeper. We should be safe. We shouldn't be gouging, but okay, we're going to go to tool axis. I believe we just leave all these things at default. You can set the angle that the cutter leads into the cut. There's maximum fan distance, which is how far it can go before it has to make a linear move. And then we're going to go on to linking. And I think pretty much everything on here is going to be default, except for I hate the vertical lead-in, so I may have already set it at 0. All right, so there's our cut, and it's the center line of the cutter. And if we simulate it, we can see what it does. Okay, so this is a swarf cut. You notice it's kind of tilting, and then as it rotates, and then it straightens up. That is set by that fan distance. Okay. Again, that's leaving 100 thousandths. Plus, it's not machining the fillets that are normal to the fixture. Those will come back and clean up with a ball mill with a different command. Okay, so we're going to copy or duplicate. And we're going to right click on the swarf and we're going to duplicate it. We're going to call the first one swarf rough. That way we know the difference, and when we know what's going on when the machine runs, the operator can tell. And then swarf finish. What we're going to do is modify the settings on swarf finish. Oh, forgot to delete the one there. We're going to modify the settings and just use the same geometry selections. So we can skip the first few tabs here. And we go to the passes, and what we want to delete is this radial stock to leave. I'm going to set that at 0. Okay, now the cutter will skim the face and remove 10 thousandths from the face. Give us a nice finish. Really shouldn't have to change anything else. But when it goes around, you can check multi-axis, but we really shouldn't have to change anything on these settings. Okay, and so it's hard to tell what's done, but it's cutting ever so slightly into the face of those chamfers so that they are a nice clean cut. Okay. Now we could have sped up the RPM and maybe slowed the feed rate down and get a little bit better finish, but we'll see how it kind of turns out. It should be a pretty nice finish. Now this could have been done 3-axis with a chamfer mill. And that's actually how we're going to do the opposite side. So it'll be interesting to see compare the finish between the two different processes. All right, next. Oh, I forgot to change the name of my setup. Mine didn't get changed to match the program, so it's just good to have that match your NC, and it goes into the notes at the beginning of the program. And I'm calling this Op 2 because Op 1 really is to cut the dovetail that puts this into the fixture. All right, so now we're going to cut this fillet or round feature. We make it with the fillet command, but that's a round because it's an exterior radius. And we're going to use a multi-axis command called multi-axis finishing. It's really intended to do like floors and pockets and walls, but we're going to use it for this. And we're going to use an 1/8 inch ball mill to do contour milling and a surface contour milling. Some places call it ball tracking because you could track a ball of the tip of the cutter across the surface, but I haven't heard that one recently. Alright, so what we have to be very careful with is the holder on here. Now the holder and the cutter are modeled after the VF1s, so we really need to make sure that the cutter that goes in the holder is smaller and longer. Help us avoid some issues. And you will see some collisions on the very last step of this part that it's because the holder is not modeled accurately. Okay, so we're changing our RPMs to 6,000, speeding it up, 60 inches a minute. This is surface cutting, so it's not taking a great deal of material off. And we're going in very small steps, so we want to go quickly. Now down here is the shaft and holder information. You can put extra clearance for the different tool geometry on here. The defaults are as shown here. I don't think we're going to need any extra clearance, but as you get experience, you know what holders are in your machine, you can put some collision avoidance numbers in here. The rotation of the 4 and 5 axis is mainly dictated by the gauge length of the holder. And so you need to make sure that that is set up accurately in your tool library, or it'll be calling for rotations at different times. Okay, we're going to go on to the Geometry tab. And in the Geometry tab, for this command, we need to select 2 types of geometry. We're going to be machining with this fillet here, and we're going to call that a wall. And we're going to use the scallop type. There's a couple different versions of it. It cuts in a profile that mimics one of the edges. In this case, we're just going to follow the profile of the floor, which is the bottom of the pocket. Okay, so we're going to select the floor, which is the bottom of the pocket. And our wall is the fillet. We could include the vertical edge, but we're not going to. And again, we're going to set our z-axis and our x-axis so that the machine knows what orientation to rotate to, even though this is normal to the platter at the moment. Next, we're going to select the part model to differentiate it from the stock. And so we pick on the body for the part itself. All right, so down here we have our different features. We have the model, we have the floor, and we have the wall, and we can put clearance. So we're going to put clearance of 10 thousandths from the floor because we don't want to gouge into the floor. So it's just going to make sure the tip of that ball cutter doesn't touch it. Okay, next we're going to the geometry clearance tab. We're just going to leave it on automatic. And then we can go to the passes. We want to do much finer passes than the default, which looks like it's about a 1/16 of an inch. We're going to do much finer step downs than a 1/16 of an inch. So we're going to put in 5 thousandths, 0.005. And we want to climb cut our tool axis limits. This limits how much angle a cutter can go on, and you can get in trouble if it goes over too far and hits the part. So we're going to set it at 80. 110 might have been okay, but. And our last tab, that's all your clearances. We're going to leave those at default. Okay, and it takes a little bit of time to process. Depends on how fast your computer is. Okay, and there's our cut. So it spirals down starts at the top and spirals down, keeping the center of the cutter from not engaging the material. So it should be cutting with side flute of the ball. Okay, next we're going to simulate this so we can see what it does. And we can see what we've done so far. So it's going in a counterclockwise direction, which is climb cutting on an internal feature. And it's doing only 5,000 steps, and then it's gonna, roll its way down that fillet. Hopefully we'll get a pretty nice finish. What's going to be interesting is the other side we're going to cut with a 3-axis moves that's similar using the same ball cutter. So we'll be able to see a difference in the finish. Or not. And we retract back out. So there, it looks like it did a pretty good job. Doesn't look like it hit anything.